Last time we learned that moments are forces times distance, and in vector form are r cross f. Let's look at some further concepts for moments. I'm going to talk about moment about an axis, then I'm going to talk about couples, force and couples, simplification of loads, and finally distributed loads. First, moments about an axis. You've learned how to calculate moments around a point. You have a point here, you have a force F, and remember you have this force line and you take any R to that force line, and M about this point O is just R cross F. Sometimes you want to know moment about an axis. There are two methods to do this, a scalar method and a vector method. Let's talk about moment about an axis, the scalar method first. Well, moving on, here's the strategy to get the moment about an axis using scalars. You have an axis here, let's say axis AB, and you have some sort of force F in 3D. What you have to do, which is difficult in 3D, is to find this distance d that is perpendicular to the axis and to the force. Well, you have two lines, A, B, and F, in 3D. You can find, if you're clever, the distance d that's perpendicular to both those lines. And if you're able to do that, the moment about the axis AB, it will be just F times D. Everything in here is a scalar. MAB is a scalar, F's a scalar, and D is a scalar. This is hard in 3D to get this distance D. But if you can do it, M is F times D. Let's actually talk about what a moment about an axis is. In this picture here, somebody's pushing on this tire iron, and here's the view, a drawing of it there. And if you take R cross F, you'll get this moment about O. So that's moment about a point. Well, you might want to know what's the moment about the y-axis. This would be moment about y-axis, and this is the total moment about O. You can see that sometimes you want to know the moment about an axis. In this case, you want to know the moment about the y-axis because we want to see how much torque is on this part of the tire iron. So the easier way to do this, moment about an axis, is to use vectors. It's funny that in this case vectors are easier than using scalars. Remember that moment is a vector. We had this moment O, about O. And if you want to know the component of this moment about an axis here, let's just call this axis A, B. If you want to know the moment about there, remember the moment's just a vector where you point your thumb and it spins around the axis your thumb is pointing on. So if you want to know how much of the moment is spinning around AB, just point your thumb along AB and point it with a unit vector. And remember, M, or any vector, dot a unit vector, is a component along that direction. To get M about AB, you just take the moment about the point O, which is on AB, and dot the unit vector AB. So moment about an axis is just the component of the moment vector along that axis. All you have to do is find the unit vector and take the dot product. Let's look at this tire problem again. Try to get fancy here. I made the steps in the order of the rainbow or the color wheel: red, orange, yellow, green, blue, indigo, violet. Step 1, and I see a mistake here, calculate the moment about a point. We want the moment about O. We're going to do R cross F. Step 2, find the unit vector along the moment axis you want, and in this problem we want it along Y. And then take step 3, take M0 dot UY, and that'll be the answer. Let's do an example. In this example, you're clamping down this weird piece of metal, and you're worried that it's going to spin around AB. You're tightening down A and B real tight, and you want to find what's the moment around AB. Okay, the order of the steps. The red step, calculate the moment about A. The orange step, calculate the unit vector AB. And the final step, yellow, take the moment about A, dot the unit vector AB. That's the yellow step. Okay, the first step is getting the moment about A. One way we could do it is that R cross F. But remember our little thing about transmissibility. If that's your force vector F, R can be to any point that's along this line. Any of these R's will, of course these are vectors, any of these R's, R cross F will give the same moment. Step red, moment about A. We could take R from A to C, but the smart, or akamai in Japanese, way to do it is take the R from A to D, because this transmissibility, F goes through point D. The moment value then is the force F, which was 300 newtons times the distance was 0.6 meters, so 118 Newton meters. And the direction by the right-hand rule is in the y direction. So instead of using R cross F, we can immediately get M is 180J. Again, F was 300 newtons, and the distance from A to D was 0.6 meters in the original picture. Okay, and now we need step orange, the unit vector from A to B. In the original picture, it was 0.4 meters in the X and 0.2 meters in the Y. To get the unit vector, you have to divide by the length. And here you go. There's the unit vector. I guess I should change my pen to orange. So here's the unit vector right there. That's step orange. And all that's left is to take the dot product of M about A and the unit vector. That will be step yellow. Finally, the yellow step, we're going to take M dot U. In the red step, we got M about A. In the orange step, we got the unit vector from A to B. And all we have to do now is just take M dot U. And remember, the dot product is just the I components times the I components plus the J components times the J components, and the Z components times the Z components. And here you go. This is the final answer. If you want to turn it back into a vector, that's a scalar. All you have to do, remember, when you want to change a scalar into a vector, is multiply it again by the unit vector, which we got in the orange step. So we need to multiply by that unit vector right here, and then in vector form, this is the answer. There's a shortcut to moment about an axis. You can read the derivation in a book. I'm just going to tell you what it is. If you want U of A, the unit vector of A, dot R cross F, which is a moment, so remember, the red step was the moment, R cross F. The yellow step was the unit vector A. If you take the determinant of the unit vector in the first row, R in the second row, and F in the third row. We're replacing the ijk with the unit vectors there. This is a triple scalar product, and that will give you the moment about an axis. Now, why would you want to do this? It's convenient because if you have a decent calculator, taking the determinant is in your calculator, and then you just type these 9 numbers and press the button and it'll come out. This is what it would look like. We'll redo the example. The unit vector from A to B. Notice we still have to do all the steps. That was the yellow step. Is right there. You need R. Remember, we took R to D instead of to C because of that transmissibility concept. And finally, the force was this vector. There you go. You just put the R vector there. You put the unit vector here in the first row. You put the R vector in the second row. You put the force vector in the third row. Punch that in your calculator. Hit the determinant button, and that's what comes out.